Welcome everybody. I am Pankaj Gupta, Associate Professor in ABES Engineering College, Department of Electrical and Electronics. Now today I will teach about measurement of three-phase power in three-phase circuit. Now for measurement of power in three-phase circuit, we require a meter that is known as wattmeter. Now power in three-phase circuits consists of three parts. First is your active power, that is represented by capital P, that is VI cos phi, and the second is reactive power, that is represented by VI sin phi, and the third power is apparent power, that is V into I. Here we are talking of active power. Here we are talking about active power. So in active power the formula is VI cos phi. Here it is the product of the voltage and the current. So the wattmeter should be able to measure the voltage and the current. Now the current, the wattmeter is connected to a load which is connected in series with the source. Here the coil in series with the load will measure the current, and that is represented by M and L, by the alphabets M and L. Since voltage is measured in parallel with the load, so here it is represented by C and V, that is nothing but the pressure coil, or that is also known as voltage coil. So here the wattmeter measures the power across these two coils. One is inductive, the other is your resistive coil. So measurement of power in three phase is done as in star as well as in delta. So here first we will discuss how is power measurement done in star connection as well as in delta connection. So first is your star connection. Measurement of power in three-phase circuit is done by three methods. First is your 1 wattmeter method. Second is your 3 wattmeter method. And the third is your 2 wattmeter method. Now in 1 wattmeter method we will only utilize 1 wattmeter in one phase. Here we have three phases, here we will only use 1 wattmeter. So the total power will be, assuming that the system is balanced, it becomes 3 times of W. In case of 3 wattmeter, we have got 3 wattmeters in different phases connected. So here we will have total power is W1 plus W2 plus W3. But in 2 wattmeter method, we are only utilizing 2 wattmeters, that is W1 and W2. So that here also the total power will be W1 plus W2. Now how is this possible? There are certain disadvantages. See, if in case of unbalanced system, the actual value will not be 3 times W. But in case of 3 wattmeter method, you have got W1 plus W2 plus W3. But the same power can be measured with the help of 2 wattmeter method. hence saving of 1 wattmeter, cost of 1 wattmeter. But this is also possible for both star as well as delta. So let us first define the phase voltages. So here we will say V1, V2 and V3 are the phase voltages. I1, I2, I3 are the phase currents. So this is V1, this is I1, this is V2, this is I2, this is V3 and this is your I3. Now the total instantaneous power in the circuit is V1 I1 plus V2 I2 plus V3 I3. Now here we will apply KCL. By KCL we see that I1 plus I2 plus I3 is equal to 0. And since the two wattmeters are connected in terminals across 1 and 2, so here I3 will be equal to minus I1 minus I2. And this will be put in the instantaneous power in place of I3. So V1 I1 plus V2 I2 plus V3 minus of I2 minus I1. So taking common, V1 is equal I1 minus I3 V1 minus V3 plus I2 times V2 minus V3. Now looking into the circuit diagram, the reading of wattmeter 1 will be total voltage between the two ends, that is your M and this point. So if you move from V1, it is V1 minus of V3, and the current flowing in the wattmeter is I1. So here the total current is I1. Now in case of wattmeter 2, the total current flowing is I2 and the voltage across the wattmeter, that is V2 minus V3. So here V2 minus V3. Now comparing the readings of W1 and W2 and the final result, we find that this is the reading of W1 plus this is the reading of W2. So in the case of star connection, we can measure the total power of a three-phase circuit by using only two wattmeters, that is W1 and W2. Now in case of delta connection, here again we will define the phase voltages and phase currents. So here phase voltages are V1, V2 and V3. So this is your V1, this is V2, this is V3. Similarly, the currents I1, I2, I3. Now the total instantaneous power is V1 I1 plus V2 I2 plus V3 I3. And since it's a delta connection, so we will apply KVL. So V1 plus V2 plus V3 is equal to 0. So here minus V1 is equal to minus V2 minus V3. So the power is equal to minus V2 minus V3 into I1 plus V2 I2 plus V3 I3. So minus V3 is equal to minus I1 minus I3 plus V2 times I2 minus I1. Now let us check the results. Now looking into the circuit diagram, we see that W1 is connected to terminal number 1. So the reading of W1 will be, now the voltage across the wattmeter 1. If you are moving in the direction, it is opposite to the V3. So here we write minus of V3. And the current flowing in the wattmeter will be, applying KCL at this node, here it will become I1 minus I3. So here it is I1 minus I3. Similarly for W2, the current flowing in the wattmeter is I2 minus I1 and the voltage across the wattmeter is V2. So here it will become V2 I2 minus I1. Now comparing the results of W1 and W2 with the given equation of instantaneous power. So we find that this first term is W1 and the second term is W2. So in case of star, you have be it delta, the power can be measured using only 2 wattmeters as compared to 3 as well as 1 wattmeter. Now the advantage is this, that this 2 wattmeter method is applicable to both balanced as well as unbalanced systems. So this is considered a universal one and it is applicable for any circuit which is having 3 phases.